Hello and welcome to BitaBit Extra. This episode is requested by one of my patrons, Peter Ardivson. He wants to know more about three specific areas of RetroX. The first one is name matching, how RetroX matches the name of the games to the database. The second one is how cloud savings work. That is very interesting. And the last one is how network storage works in RetroX. So let's start with the way that RetroX makes the matching between the games that you have in your storage and the database. What RetroX does is to take the name of the game, for example this one, and all the characters that are not letters or digits are removed. For example, in this case, the spaces between the words are removed and all the letters are turned into lowercase, and this creates a code. For example, this game, Alien vs Predator, is converted into this code. If you see the code, it's the same as the name, but without the spaces and the uppercase. The second example is the same game, but is written in a different way. This has a dot here. But as we take out anything that is not a letter or digit, the dot is gone and the code is the same. So in this case, this game has a different name, but in the end, it's the same game, so it has the same code. This is another example with the game GoldenEye that you can find written in different types depending on the collection of the games. In this case, these three versions of the game will end as a one code because this colon and this dash will be removed. Also the spaces and the uppercase letters. Here is another example where the game has these marks. You can find a lot of games having this kind of marks, and these are removed. So in this case, this game is identified by the code Atari Tetris and nothing else. This is a common technique used in programming, where you apply something that is called normalization. You take something that has several ways to be represented, and you turn it into something that is unique. So, using this method, it doesn't matter how different are the game names, they always end like a code, as this example. There are a few exceptions in some systems. For example, MAME and Final Burn Neo already use encoded names. They use, for example, mslag.zip, and the code is mslag. The game name is already coded, so you don't need to code it again. ScanVM also has codes for all the games that are supported by the emulator, so there is no need to create new codes. If you go to retrox.tv/scanvm-games, you will see the list of games and the codes that are used to recognize these games. The final step is to take the code and recognize the game. So this is the inverse part. In the first part, we saw that the game name is converted into a code. Then, with using that code, the game is looked up in the database. So, if I find, for example, mslag, I know that the game is Metal Slug. If I find, Tentacle, it's a different code. It's not DOTT, it's Tentacle. If you find Tentacle, you will find the game Day of the Tentacle in the database. Now, how the game info is pulled from the database. Currently, there are three sources. The first one is the RetroX server. In the RetroX server, you can find the artwork for the game. You will find the known cover and screenshots for the game. And you will also find metadata, like the game description, rating, the name of the developer, how many players. That info is on the server, on the RetroX server, and it's downloaded automatically. If I have the game Metal Slug, the server looks for the mslug info and it finds the artwork and the metadata. Sometimes not all the metadata is found and you can provide it yourself. There are two ways to provide it. One is using Emu Movies and the other one is using local storage. For example, you can add your own artwork to the games in your local storage, and RetroX will use that one. If you don't have the artwork in your local storage, you can still ask Emu Movies to download. It's not exactly that way. What you do is to use a sync option in RetroX that connects your games to Emu Movies, and all the artwork found is downloaded. Also, you can download from them the videos for your games. And this is something new. In a new themes, we are using 3D boxes in the theme we did with Stuart, Paul James. And for a future theme, we are downloading game logos. This type of artwork is not in the RetroX server yet, but you can download it from Emu Movies. So RetroX will use the code for the game to look for the artwork and metadata in the RetroX server only if you don't have it in your local storage. Now, if you need to use Emu Movies uses another way of matching the names. So I only send the names as is. I don't use any type of code. I just send the names and Emu Movies find the artwork for that game. They use their own matching code. Now, Peter asked me about a bug that he had. He told me that in the game list, there's one game that appears at the top of the list. And that's very strange. We have tried to find the cause. We still haven't found it. And well, here's an explanation. Maybe it will give some ideas of what could be wrong. The list of games that you see in RetroX use the file names. It doesn't use anything related to the database. You have a file in your storage with a file name, and that file name is used in the list. So there is no relationship between the codes or the database. Computers don't see letters, digits, or symbols. Humans do. What the computer see is numbers. So every letter or digit in your file names internally are only numbers. What the computer does is to have ways to transform or to interpret letters, for example, as numbers. There are two very well-known methods of making this transformation between text and numbers. The oldest one known to us is not the oldest one, but it's one old method. It's called ASCII. There you have 127 codes for all the Western text. So if you are in Asia, this code is not for you. There's another method that is called UTF, where you have codes for text coming from all over the world. So if you have Japanese text, for example, you need UTF. ASCII will not be appropriate for that. So your game names internally are represented as ASCII code or UTF code. Here you can see a sample of the ASCII codes for certain letters, for example. Here we can see that the letter A is internally stored as the number 65. and the letter A in lowercase is 97. So what the computer sees is this kind of numbers, not the letters or digits, neither the symbols. So the name of your game is handled internally as UTF bytes. For Western text, this is the same that using ASCII. Here are two examples. You have two game names, and they are converted to these sequences of numbers. For example, the 32 is the space between. These two are the number 23, and the numbers here are the bytes for this text. So internally, when the sort is done, what the computer does is to check the numbers. So in this case, 101 is lower than 115, so this name will be before this one. Now, what could go wrong using this method? There are some ASCII codes that are not visible. They are not a letter or digit or symbol. For example, the number 7 is the representation of a bell sound. The 8 is the representation of the backspace. So you will never see these codes, but you can have this code in your file name. For example, you can have the file name spot, but because of an error, you can have the ASCII byte 7 here. So instead of seeing the letter S, the computer will see the number 7. So in this case, the number 7 is lower than the number 101. So in this case, spot will be up in the list and before the word I. It will be shown as not the right order, but internally is the right order. Peter, I think that this may be your case, but to make sure, maybe you can send me your files and I can make a test to see what's going on with your game. Now, how do cloud saves work? This is the second question. First, we need to know how saves work. An emulator that is running on RetroX is a software that is implementing a hardware. And hardware contains register and memory. These are two kinds of variables. So when a game is running, for example, the game is running and the CPU is running the code and the video processor is showing the game, internally the CPU is handling memory and the video processor is handling its own registers. But for the emulator, this is only data. So what the emulator does is to take the memory and the registers, and the emulator writes this data to the storage. So if you save the register and the memory of the machine, you are saving the running state of the machine. That's why it's called a saved state. So at any moment, the emulator can load this data, and the CPU and the other processors of the hardware being emulated will load the state and will never know that the machine was shut down, for example. Not all emulators in RetroX are supporting saving the states at this moment. For example, MAME, I think MAME 2003 is the only one that supports saves. This is because MAME is an emulator for many different types of machines. So to allow to save the state, you have to implement the saving state for each kind of machine, and they are too much. So that's why I think that it is the reason that there is no save state in several versions of MAME. In the case of DOS, I don't know exactly why it doesn't support saving state for now. I think that it's only a problem of the emulator being used. Additionally, some systems and some games can also save the progress of the game, but using a different method. This kind of method to save the progress is the method that they used in the original hardware. For example, in the PlayStation, they have a memory card, and the game can save the progress to that memory card. So the game only saves what it needs to resume the progress in the future, there is no need to save the state of the machine. So these kind of files are very small, except I think for the PlayStation Portal. They are quite big. But in general, this format requires less space. The only problem is that the game has to let you save the state, the progress, I mean. So it depends on the game in what place you can save the progress. In RetroX, you can store both type of saves in the cloud, the state of the machine, or the saved files, which is the name for that I'm using for the memory cards, for example. So if the states or the progress finally are only files, these files can be sent to the cloud to be saved. What I did in RetroX is that every user has a list of files, and the files, of course, the files and a list of files. And for each file, there is a number associated. Here you can see an example. I took a random user, and if you see, here are some save files for games for the PC Engine. And each file has a number, a sequential number. In RetroX, I use the name version number for these numbers. If you know something about databases, this normally is called a sequence. I use the sequence as a version number. So I know that this file, for example, is newer than all these other files. So looking at the version history, I can know what are the current saves. So how this version number is created to begin with? When you start a game or when you're running a game, RetroX looks into a special folder to see if at some point the emulator creates a new save or a new state. If RetroX finds a state or a new file there, it adds it to a list of files to be uploaded to the server. And if there is a network connection available, the file is uploaded. So this is very quick. I think that every 5 or 10 seconds, RetroX is looking at the files to see if there are new files to be uploaded. Once the file has been uploaded, the server returns a new version number, and that version number is stored in the device. Let's see this example. Here we have the device storage, and the storage will contain the files that you want to save and the version number of the files in the server. So when RetroX is looking for new saves, let's think that a new save is found. That save is uploaded to the server, and the server returns a new version number, and that version number is stored. And that's all. It's quite simple, this part. A new file is found, uploaded, and a new version is created and stored. That's all. Now, how this version number is used among all the devices. Here in the storage, we have a version number, but this version number is for this device. If you have another device, you may have new saves, so you will have a different version number, and the server will have that number. So RetroX will ask the server which is the current version number. If the version number is higher than the one in the storage, then RetroX will ask for all the files that were uploaded between that version, the original version, and the new version. You can see this process when RetroX is booting. Every time RetroX boot, it sends the version number to the server and receives the new files. Also, this step is done when you start a game. Sometimes you will see that you're starting a game and you will see at the top a circle moving. That's when RetroX is asking the server about special configurations for your game. And also it's asking if there is a new version of the saves. If there is a new version, RetroX will download the files. And the new version number will be written here. And the last question is, how does network storage work? What I did in RetroX is to separate between the storage of the files and what RetroX sees. I did a method that doesn't require RetroX to know where the files are. RetroX doesn't know exactly where are the games. What I do inside is that I save the location of each file, and that location has this structure. There is a type, a colon, and a path. The type defines the storage of the path. For example, the type local is for all the games that are stored in local storage. So this path is inside the device. But if I use a different type, for example, G drive, this type indicates that this path is in your Google Drive account and not in local storage. The same for Tonido, for example, another cloud service. This indicates that the file is in your Tonido storage in this path. So for each type, there is a file handler or virtual file handler, which is the name that I use. A virtual file handler is a piece of code that knows how to process a certain type of file or location, in this case. In programming, this is called abstraction because RetroX sees something abstract. It doesn't know the implementation details. It doesn't know about the protocols of G drive or the protocols of Tonido. It doesn't need to know. It only knows the location. Here you can see how this works. This is RetroX, and the first step is to know the location of the game. And the location will be a name like we see in the previous slide. And the location is processed by a virtual file resolver. The virtual file resolver will look at the type and will find the programming code that knows how to handle this type. So there are different file handlers for each type. For example, there is a Google Drive file handler, a Tonido file handler, a Dropbox file handler, and each file handler knows how to talk with each service. Here you can see that RetroX doesn't access any service. RetroX asks the virtual file resolver, and the virtual file resolver asks a file handler to do the magic. Finally, the file is downloaded and stored in the local storage, and the emulator runs the game. As you can see, the emulator always uses local files. So, Peter, you asked about the latency. As you can see, there is no latency because the emulator is using local storage. So this is, for the emulator, it's like you have the game in your local storage. The ones that do the magic are the file handlers. Here you can see the real code from RetroX where I create the file handlers. For example, here you can see the handlers for Tonido, the handlers for NAS, the handlers for Dropbox, G Drive, OneDrive. Also, you can see there are special handlers for compressed files. So for RetroX, a compressed file is another storage. RetroX asks for example, the zip handler the same way that it asks the Tonido server. And also you can combine both. That's crazy. For example, you can have a zip file into your Tonido server. So RetroX will first bring the Tonido server, it will return a zip file, and the zip file handler will process the zip file. It's it's crazy, but I don't recommend you to use compressed file because finally all the files will end in local storage. It doesn't matter where you have the file, you will need local storage to contain the file. Well, about the network storage, we can say that there is the good, the bad, and the ugly. The good is that adding a new source of files is a matter of writing a new virtual file handler. It's quite easy. So I only need to write another one of these to have support for new types of storage. The other good thing is that most sources are compatible with this approach. I plan to create file handlers for OwnCloud and another one, NewCloud, or something like that. Nextcloud, Nextcloud, OwnCloud, Nextcloud. I also want to create a method to use your home computer to provide the games. So you can use a simple private network to provide games to RetroX. The bad is that most external sources are always slower than the local storage. Even listing the games is very slow. The other bad is that, as I said before, is that the emulators need the files to be local and they must be downloaded to the device. And the ugly is that third parties, Dropbox for example, or Google Drive, sometimes they make changes and they break things and the handlers must be rewritten. Oh, that's horrible. And also some protocols are horrible from the beginning, and this is the case of the NAS devices that use the CIFS and SMB protocol. I hate it. Another element is the Nvidia Shield. The Nvidia Shield provides a way to access network storage in a very easy way. You can mount your NAS file system into the Nvidia Shield and all the apps will see that device as local. So this is very magic because the operating system provides the files and you don't have to download the files. They are streamed from the server. The only problem that you may see is that reading huge files like CD can be a bit slow. So if you, for example, if you're running a PlayStation game and there is a big load from the CD, it will be quite slow. And unfortunately, this kind of streaming can only be done with the NAS file system, because I've seen that the cloud services doesn't provide a way to stream files. So you have to always download the full file. So that's a shame, but that's the way it is. I hope you enjoyed this video. For me, it was very fun to do it. If you want more videos like this, you can join my Patreon campaign. So you can ask for new videos. I plan to do a maximum of 10 per month, 10 videos per month. So stay tuned. I hope new videos will come soon. Maybe not in English, unless you request it in English. So until the next time, see you. Thanks.